Hey, welcome back everyone to another video demonstration of yet another example from this textbook. The design example that we'll be looking at today is this one in chapter number 5, listing 5.4. This is a simple design entity, in this case using a media machine based description for detecting rising edges on an input signal. So I assume that you already started this. If you wanted to take a quick look at how exactly this will operate, the input signal level shown over here, whenever it changes from 0 to 1, so you will have a rising edge. The output peak will be 1 for a while, and then get back to 0. Whenever the level input signal will change again from 0 to 1, a rising edge, then that tick will be generated to signify that rising edge just happened. So to test this edge detection circuit, described as a mini machine, I crafted this testing circuit, which essentially instantiates that edge detection circuit that takes as an input the signal inverted that comes from a push button on the DE1-SoC board, and the reset signal that also inverted that comes from key 0 push button on the DE1-SoC board. The output drives directly the first red LED on the board. The edge detection circuit requires a clock signal as well, that I generated a clock divider, a behavioral description of a clock divider that takes as an input the 50 megahertz that comes from the crystal oscillator on the board, and slows it down to about 2 or 3 hertz clock period. I have already created the Quartus project where I brought in the edge detect, that VHD, the clock divider, and the top level design editor. The edge detection VHDL code is the listing 5.4 itself. The clock divider, you see it here, takes as an input a signal, generates an output according to some counting tricks over here to slow that down enough times, something that can be controlled through some of these constants, to be of about 2 or 3 seconds. The top level, as you can see it here, takes as an input the clock 50, and the reset and the level input ports that come from the 2 push buttons from the board that we'll see later on. The architecture description you see over here, architecture, my structural 2 component declarations, the edge detect and the clock divider, a couple of signal declarations that will help us wire up those components just like we saw them here in the top level block diagram of that testing circuit. That is shown over here, the port mappings of the clock divider and the edge detect circuit, and here you see those 2 inverters that I needed over here. So I have already compiled, did the synthesis, placement, routing, generated the programming file, and I have already programmed the FPGA board using, of course, the programmer. So now let's see how this works. So here is the program to FPGA board. This is the key 0 push button. This is the key 1 push button. This is used as the reset input signal. This is used as the level input signal that whenever we'll have a rising edge, the first red LED should light up, driven by that tick output signal out of the edge detection circuit. So let's reset, and then let's send an input signal. You see, I push, and then I keep it, then I release it. Doesn't matter how long I keep it pressed, doesn't matter how long that logic 1 stays on the input level signal. the output peak will always be more or less of the same duration. So as you can see, this works correctly.